Okay, guys, today I'm going to talk to you about the ideal gas law. The ideal gas law is used when you have non-changing conditions. The laws we talked about before, Boyle's, Charles, Gay-Lussac's, and combined, all have changing pressures, volumes, or temps. This, you don't have that. And I'll show you an example problem in a minute. But when you use this gas law, you have to do a little bit of algebra to get your variable where you need it. The first thing you need to know is what pressure always has to be in atmospheres. Volume has to be in liters. N is moles. So if they give you grams, you got to convert them to moles. R is the gas constant. It's always the same number. It's 0.0821. Now, if you look on some sheets or some websites, they may have a different R. It might be like 0.83. That's when they're using kilopascals here. I always keep atmospheres. That means my R is always this value. Temperature is always degrees Kelvin, which we already talked about before. So anytime you do an ideal gas law, these are musts. You have to have them in these units. Other than that, all you do is just put your variables in and solve for the unknown. Okay, so I'm going to show you an example on my screen here. I found this one online. Number 2, a sample of 1 mole of oxygen at 50 degrees Celsius and 98.6 kPa occupies what volume? So I would always just recommend just writing out the variables. So just go P, V, N, R, T. We always know R is a constant. Temp, I'm going to convert right now. So 50 plus 273 gives you 323. So you want that number. Moles is 1. Volume, we don't know, and that's what we're looking for. And pressure is in kPAs. Now, you can look up the R constant for kPa. I don't like to do that because this one is just the one I've always used. So I'm going to do a quick pressure conversion. I'll kind of do it down here so you can see what I'm doing. So 98.6 kPa. We're going to do kPa to atmosphere. And you have to go back to the thing in the notes that I showed you on pressure conversions to know this. So every 1 atmosphere is 101.325 kPa. Hold on 1 second. I got to go get my calculator. Where's my good calculator? Where it is? I don't know where it went. Oh, it's right here. Okay, sorry about that. So I'm going to punch that in. 98.6 divided by 101.325. And that'll put me in atmospheres. And that's the number I want to put up here in pressure. So 0.973. Okay, so for this problem too, we got everything ready to go. All I'm going to do is come down here and just plug things in. So 0.973 times V equal to 1.00, 0.0821, and the temp was 323. And now all you do is solve for V. So that would be 1.00 times 0.0821 times 323 over 0.973. And that gives me 27.3 liters. Okay, so there's an example of that one. I'll do one more and then I'll be done. Let's go down here. I don't know. Let's try number. That looks like nastiness. Let's try number 4. Okay, so we're going to go P, V, N, R, T. We always plug in the R. Let's deal with the temp here. 27 converts to what is that, 273, 300. Okay, you guys see my example I'm getting that from, right? Okay, so N is 10.0 mole. Now, a lot of times they'll give you grams and you gotta do a little mini conversion to moles. This one wants volume again. No, it doesn't. This one wants pressure. The volume is 1.50 liter, and this one wants pressure. So just plug it in again. Here we go, P, 1.50, 10.0 mole, 0.0821. That's the R value, and temperature is 300. And we're gonna solve for P. So 10 times 0.0821 times 300 all over 1.50. Ten times 0.0821, didn't record it, times 300 equals, and then we're going to divide by 1.50. And that gives me a pressure of, well, that seems high. I'm going to check it again, 164 atmospheres. Woo! Let me check this again. 10 times 0.0821 times 300 divided by 1.50. 164 I got. Okay, well, we're going to go with it. That's really, really high pressure because we live in roughly 1 atmosphere of pressure. That's 164 times our pressure on Earth, which would crush you instantly. So, but that's the answer, and I'm sticking with it. Okay, well, I hope this helped you. If you need any help, let me know.